Hey, today we're going to start off of page 62 on our INB, where we'll be comparing linear functions and exponential functions. So if you read the heading or the beginning paragraph, it says linear and exponential functions share many characteristics. This is because they are based on two different but similar set of principles. So first we're going to look at linear functions, and they are based on repeatedly adding the same amount, which is called the slope of the equation. So we're going to look at y equals mx plus b, which is our slope, is our m, and our b is our y-intercept. In a word problem, we would call that our initial amount. And I took a couple points off of this line and I just created a table. And if you notice this table, all of my y's, every time I continue in this pattern, I am adding 2 units, which this defines a linear equation. So as I'm going up on x's by 1, what I'm really focusing on, my y values are increasing by adding the number 2 to each. Let's compare that with our exponential function. So our exponential function that we started with was y is equal to a times b raised to the x. And we learned that a was our initial amount, just like b in linear was also our initial amount, or our y-intercept. And here my b is going to be my multiplier. This is what I'm going to be multiplying by in my pattern. Okay. Now, if we look at the form below here, I still have my initial amount. However, remember, inside the multiplier is your rate. And if I wanted to know what my rate is, it would depend if it was a growth or decay. So I have this growth that has 1 point plus r, which is my growth, and then the 1 minus r, which was my decay. We're going to be focusing on at the whole b, the base, that's going to be the multiplier. So if I look at this table over here in this exponential, know how it curves and goes up, kind of like a airplane taking off or a rocket. And I put some points down, and then I noticed every time I increase or go from top to bottom on my y's, there's a pattern of multiplying my y's by 2 as my x's go up by 1. And this is a definition of a exponential, by multiplying your outputs. Okay. Our next is we're just going to explore some more of this, look at a couple of tables, and we're going to say, let's take a look at our outputs. Are we going to be adding them, or are we going to be multiplying them? And so we're just going to look at table number 1, and we're going to say 0, let's try adding 3. So I notice 0 plus 3 is 3, 3 plus 0 is 6, 6 plus 3 is 9, 9 plus 3 is 12. I notice as my x's go up by 1, I am adding 3 constantly to my outputs or my y's, and that defines a linear equation. Why? Because I'm increasing my y values by adding 3 each time. Okay, and we know that that's my slope, right? So this 3 is going to be my slope. So if I look up at the equation y equals mx plus b, I have y is equal to, well, my m is 3. So 3x. And now I'm after my y-intercept, or my starting amount. Remember, your starting amount's always where your x is 0. So I look up here, and I said when my x is 0, my y is also 0. I'm going to put a plus 0, but we wouldn't write that, but I'm just going to do that for reference back how I got that 0. And now I'm just going to graph. We should be used to graphing, starting off at 0 at my y-intercept, or my initial amount, and I'm going to use my slope of 3 over 1. So I'm going to go up 3, right 1, up 3, right 1, and then I can go and switch and go the opposite directions, down 3, left 1. down 3, left 1. Did I go down 1? Yep. Okay, and there's my graph. Good, let's take a look at the next one. And if I notice on this one, I might start by adding 2 again, and I get 1 plus 2 is 3, and then 3 plus 2 is 5, but I forgot 9. So adding 2 does not work. So let's try multiplying. 1 times something is 3, 1 times 3 is 3, 3 times 3 is 9, 9 times 3 is 27, and then 27 times 3 is 81. So this one is going to be exponential. Why? Because I'm multiplying my outputs, or y, by the same value, which is 3, as my x's go up by the value of 1. So y, I'm increasing my y values by multiplying by 3. And both of these are an example of increasing. You could also decrease. That would be, instead of adding a positive number, I could add a negative number. That's how I could decrease a linear. And we know we can decrease a exponential, its outputs, by multiplying by a number that's less than 1, like 1/3 or 0.5. But these were both increasing my y's as I was going from smaller x values to greater x values. So next is my equation. Y is equal to a times b to the x. My multiplier is my b, which we found was 3 raised to the x. And I'm going to, the same way I found my initial for the linear, I'm going to do for my exponential, is when x is 0, my y is 1. Normally wouldn't write 1 as a initial for my exponential, but we'll do that just so we can see where we got it from. And then I'm going to graph my exponential, and I'm just going to need my table of values for this. And I'm going to start off at 0, 1, 1, 3, and then 2, 9. And if you remember, it looked like a rocket taking off, and there's this thing called an asymptote at y equals 0. It's this horizontal line. And it kind of gives me a place where my exponential is going to approach, but not cross. It's not going to go below this line. It's just going to be really close. And then it's going to come and go straight up like that. Okay. So let's look at a couple more. Let's take a look at this next table. I like try adding first. So let's do 3 plus 3 is 6. 6 plus 3 is 9. That didn't work. So it looks like multiplication. So 3 times 2 is 6. 6 times 2 is 12. 12 times 2 is 24. 24 times 2 is 48. Definitely exponential, because as my x's are increasing by 1, I'm multiplying by 2, so I'm increasing again. So this is a growth. And so explain, because we are multiplying y's by 2. Okay, so I know this is a growth, and the multiplier is my base. So if I'm looking at y is equal to a to the b to the x, a multiplier is the base b, which has the rate in there. And my initial is when my x is 0. This time I have an initial amount of 3. There's my equation. And I'm going to move on to the next one. So I'm going to start off by adding. So 3 plus 2 is 5. 5 plus 2 is 7. This looks like it's definitely linear, because I'm adding the same much as my x's are going up by 1. I'm adding 2 to my y. And that's explain why, because adding 2 to every, so it's I'm adding, not multiplying. Okay, and my equation, I know that my m is 2. And now I've got to look at my y-intercept, so that's where my x is 0, or my initial amount. So I'm going to use the equation of y equals mx plus b, where m is my slope and b is my starting amount or my y-intercept, which is 3. And this asks me to graph both of these. So I'm going to change a couple colors. I'm going to do my exponential in blue, my very first one. So I'm going to go to 0, 3, and then 1, 6, and then 2, 12. Now I'll go up to 10. I'm just going to do a couple more I like to have 3 points. And I remember an exponential looks like a rocket taking off, and it's got a landing pad, which is this horizontal asymptote at y equals 0. This is where it takes off from. Doesn't go underground, so you're not going to go below the line. You're just going to use it to take off and then connect your 3 points. And there's my exponential graph. And now I'm going to change my color to red, and I'm going to graph my linear, which I'm going to start off at 0, 3. Well, I noticed that I started off at 0, 2 on this one. Let me change that up. So I'm going to start off at 0, 3, same spot. This time I'm going to use my slope, and I'm going to go up 2, right 1, up 2, right 1, and I can go down to left 1, and I'm going to. Now it says, what do you notice about the graphs? I noticed 2 things. Both start at 3 or have a y-intercept at 3. Their initial value is the same, right? They're both a growth or a positive slope, right? And I also know my exponential grows faster than the linear. Notice, like, if I looked at 5, when x is 5, I could find, yeah, my linear is about what, right here? Maybe that's about 12. I don't know, somewhere. But no difference if I wanted to find what my output at 5 is for my exponential, just kind of looking as a graph, carry this thing all the way up. My graph is going way, like if I continued that trend, it's so much higher, such a bigger y value than my linear at 5. So I know my exponential grows much faster than my linear function when you're multiplying by 2 versus adding by 2. Okay. See you tomorrow.